Hello again. In this video, we're going to go over some of the properties of definite integrals. So let's suppose f and g are integrable functions on an interval that contains a, b, and p. Okay, so the first property. The definite integral from a to a of f of x is equal to 0. And that's because the area trapped between the function and the x-axis in that case would have to be 0. The second one says that the definite integral from b to a of f of x is equal to the negative of the definite integral from a to b of f of x. So in other words, if you switch the upper and lower limit here on the definite integral, then you have to put a minus sign in front of the definite integral. Okay, the third one basically says if you take the definite integral of f of x plus or minus g of x, then that's the same as finding the definite integral of f of x and then adding or subtracting the definite integral of g of x. Okay, the fourth one says that if you take the definite integral of a constant times a function, that's equivalent to finding the definite integral of the function and then multiplying it by that constant. So the fifth one says that if you want to find the definite integral of f of x from a to b, then you're allowed to find the definite integral from a to p, and then add that to the definite integral from p to p. So in other words, you can stop at some point in between and find the definite integral from a to p at that point, and then as long as you pick it up from p and end at b, and then add those two definite integrals, it's the same as going from a to b. Okay, the sixth one says that the absolute value of f is also integrable on the closed interval from a to b. So if f is integrable, then the absolute value of f is also integrable. And in addition to that, when you find the definite integral of the absolute value of f of x starting at a and ending at b, then what it gives you is the sum of the areas that are bounded by the graph of f of x and the x-axis on the closed interval from a to b. So essentially, when you take the absolute value of f, any part of the function that goes below the x-axis is now above the x-axis. And so instead of getting negative contributions because the function's below the x-axis, you're now getting positive contributions. And so essentially, this is a way for us to find the area that's trapped between a function and the x-axis starting at a and ending at b. Okay, so let's look at some examples where we use some of these properties. So in this particular example, we know the definite integral from 0 to 5 of this function is 3, and we also know that the definite integral from 0 to 7 is negative 10. And we're supposed to find the definite integral from 0 to 7 of 2 times f of x. Okay, well, to find that definite integral, we're allowed to pull the 2 out of the definite integral since it's a constant. And then the definite integral from 0 to 7, we're told, is negative 10. So the answer will be 2 times negative 10, so it would be negative 20. Okay, part B, we're supposed to find the definite integral from 5 to 7. Notice we're not given that information. We're only given these two pieces of information. We know it from 0 to 5 and 0 to 7, but we don't know it from 5 to 7. Okay, but we do know this. From 0 to 7, that's equivalent to finding the definite integral from 0 to 5 and adding it to the definite integral that goes from 5 to 7. Okay, and we know the one from 0 to 7, that one happens to be negative 10. And then the one that goes from 0 to 5, we know that one happens to be positive 3. Okay, and so what you can do here is, starting with this equation, you can subtract this definite integral from 0 to 5 to the left-hand side. And what that's going to give you is the definite integral from 0 to 7 minus the definite integral from 0 to 5, which is this. And that's going to be equal to the definite integral from 5 to 7, which is this side. Since we know this one is negative 10 and we know this one is 3, you're just going to get negative 10 minus 3, which is negative 13. Okay, and then part C, we want to find the definite integral from 5 to 0. Unfortunately, they didn't give us that. They did give us the definite integral from 0 to 5. And remember, if you switch these limits, you just have to put a minus sign in front of your definite integral. So the definite integral from 5 to 0 is the same as the definite integral from 0 to 5 with a minus sign in front. And we know the definite integral from 0 to 5. We were told that's equal to 3. And so the definite integral from 5 to 0 must be minus 3. Okay, part D. We want the definite integral from 0 to 6, or sorry, from 7 to 0 of 6 times f of x. So obviously the first thing you could do is pull the 6 out since it's a constant. And then we're going to flip these, the lower limit and the upper limit, and make it from 0 to 7. And then of course when we do that, we'll have to put a minus sign in front. So it's going to look like you flip these, and so you get the definite integral from 0 to 7 with a minus sign in front. And then you can factor this 6 out of the definite integral, so it looks like that. And then we know the definite integral from 0 to 7 is negative 10, so we end up with 60. Okay, and then part E, let's find the definite integral from 0 to 7 of the absolute value of f of x. Okay, this integral that we have here cannot be evaluated. And the reason we can't evaluate it is because we only know the definite integral from 0 to 7 is negative 10. But we don't know what's going to happen if you take the definite integral of the absolute value of f of x from 0 to 7. So there's no way to evaluate that last integral using the properties of definite integrals. Okay, part of the issue is we don't know which part of f of x goes below the x-axis between 0 and 7, which part goes above the x-axis. We just know that in total, the definite integral from 0 to 7 ends up being negative 10. So when you take the absolute value of f of x, it's impossible for us to know what that function is going to look like. Okay, so this is just some examples where you use these properties of definite integrals. Some of these are obvious and some of them are new. I would say that 1 is fairly obvious, 3 is fairly obvious, and 4 is fairly obvious. 2 and 5 are not so obvious, so you may want to look at those, as well as 6. Okay, so I hope you found this video helpful, and thank you for watching. Bye-bye.